All right, last one for the night. Yeah, it's 6 minutes at time. It says 11:58, 12:04 for you. But y'all are going to come up with some lame excuse saying, I couldn't do it, I didn't have time. Milbrath can do it, so can you. This is solve, it says simplify your answer, which I love. I love it when they say simplify. It's like one of my favorite words. Just makes me feel all warm and fuzzy inside. We have a property out here, and I'm going to do a kind of a shorthand version of it. Log A plus log B is condensed to be a logarithm that contains the product of A and B. So when I condense this thing, I'm going to have log of 5t. I like to put parentheses in here. Some teachers don't. Equal to 3. Now, I have a logarithm, and the understood base is 10. So I do my conversion. 10 cubed must be 5t. If this is the first video you watched, by the way, I do this. Log base b argument a equal to e is equivalent to a base with an exponent equal to the argument. So that was my base, that was my argument, and this is my exponent. That's where that's coming from, okay? 10 cubed, got to be 1,000, right? 1,000 is 5t. You divide through 1,000 by 5, and you should get 200. Should get 200. But then again, it's midnight. And my wife is like, where are you? Why aren't you home? Why aren't you home? So I got to text her back right here. This one's going to be just like the last one I did. The condensed logarithm would contain 4u. Remember, the understood base is 10, so 10 cubed is 4u. 1,000 is 4u. And if we divide out our 4, we get that u is 250. So, yeah, no problem there. Of course, you know, this is only the second question. It's supposed to be easy, isn't it? All right, so easy. Oh, we got a fraction. And the base is funky, right? 64. The condensing would give me a product of 5v on the interior of my logarithm equal to 2 over 3. When I rewrite into exponential form, this is what I'd have. What it's asking me to do here, and you can use your calculator if you must, it's asking me to take the cubic root of 64 and square the result. You know, we teach those properties in Algebra 2 over and over and over. The cube root of 64 is 4, and if you square it, you get a 16. So 16 is 5v. Now, since it's midnight, I'm going to check myself here. That was 64 to the 2/3 power. Like I said, you can push buttons in a TI-84 if you have to. 16, good. Back onto this bad boy, divide out my 5, and there's my answer. 16/5. That wasn't bad, was it? Was that bad? Apparently I got it. I already know I got it. We got subtraction. Subtraction. So here, a condensed rule for subtraction, a log A minus a log B is a logarithm that contains the quotient of A and B. All right? First one goes up top, second one goes down low. This is a log of v9ths, whose base is 64. I'm so tired I almost forgot it. It's equal to 5/6. This thing's going to be ugly, isn't it? On my conversion to exponential notation, or form would be a better thing to say, 64 to the 5/6 is v over 9. 64 to the 5/6, I feel like it's 32. Like, that's what my brain's telling me. Seems like the 6 root of 64 is 2, and raise 2 to the 5th, you get 32, but I'm pretty blasted tired. Let's see how good my tired brain is. It was 32. How about that? 32 is v over 9. There's my cockiness. I am cocky. I don't know why I am, but that's the way I am. I just love this stuff. 9 both sides. 9 times 32 is going to be what? 288? That seems reasonable. So 288 is my value for V. $288. Fantastic! God, I'm good. Let's jump up to level 3. Really? Really? Something that simple? All right, so this property is a common sense property. Couldn't tell you what the name of the property is. But it says a logarithm of base b, and this is the way I write it, whose argument is x, equal to a logarithm of base b, whose argument is y. So if this, then x is y. So the deal is, if you have a common base, drop the logs. That's how I teach it. Just drop the logs. So here I'd have 5 equals 5y. Divide out your 5 and your y value is 1. Easy stuff, kids. Easy stuff. And I know this was taught to you in Algebra 2. Doesn't mean you understood it. It was taught. Super! Same blasted property. 5w got to equal 4w plus 2. 5w got to equal 4w plus 2. Subtract your 4w. You'll have w as 2. Easy, easy, easy stuff. Easy stuff. Correct, Milbrath. Same property again. Let's bump it up, man, because it's midnight. 12:11 is what the time is. I'm ready to go home. Same property. Ooh, we have a quadratic. I love quadratics because quadratics means you get to do one of 3 things. You get to factor, you get to complete the square, or you get to do the quadratic formula. I have a hunch it's going to be factoring, but we'll find out. So we get to do r squared minus 3r plus 9 equal to a negative 3r plus 13. By the way, if you're watching this, subscribe. Subscribe, okay? I need money. I'm actually not doing this for money, but, subscribe. Shift everything left. Negative 3r minus 3r is going to be negative 6r. That, believe it or not, is a 13. 9 minus 13 is what, negative 4? Aww. Really? You know, I just said, aww. It doesn't factor. Man. Did I mess up? I did mess up. Those 2 things are in balance. R squared minus 4 is 0. And that bad boy will factor. Of course, a lot of kids won't do that. A lot of kids, and honest to God, you probably should do this. R squared is 4. All right? Which means R is plus or minus 2. Now, this needs to be checked, okay? It is very easy to get what we call an extraneous answer with logarithms when there's 2 answers. All right? In a previous lesson, I probably talked about this. If you have the log, and I like to use funny things like frowny faces or smiley faces. But if you have a logarithm that contains something, the argument of the logarithm must be bigger than 0. So these things need to be checked. What happens if I plug a 2 in? Okay? If I take that, and most kids always just throw away the negative, but if I take that 2 and I put it right there, and I'm just going to do this with a calculator so you can see it, I have negative 3 times a 2 plus a 13. I'm going to get a 7, which is okay. I had something else in my head. So the positive 2 works on the right. Check the left. The left would be 2 squared minus 3 times 2 at a 9. It's also positive. So I know that 2 is valid. I'm going to do the same with a negative 2. I'm going to take a negative 2, square it, take away 3 times a negative 2, and add a 9. Negative 2 works on the left, and just because I'm tired and want to save time, it works on the right. That would be 6 plus 13. It says if there are multiple answers, separate them with commas. One of them was negative 2 and the other one was positive 2. Be on the lookout for answers that don't work. And here's another one of these, and I'll do it just because I feel like it. And this will be the last one of the night, and I can finally go home. Too bad it's a 20-minute drive. You guys have been doing tribute videos lately. At least we have your address. And where's my tribute video? I'm doing this for you past midnight. I ain't getting paid for it either. I'm just doing it because I want you to learn the content. So we're going to cross those out because they're in balance. Let's just jump straight to taking square roots. We take away 11 from 12, we get a 1. Square root both sides. Remember that you always, when you're solving for a variable, you include the plus or minus symbol. So there's 2 potential answers. If you were to plug either the positive one or the negative one where my cursor is, you would get a positive number. If you were to plug either the positive or the negative one over here, you'd still get a positive number. They're both valid. It doesn't look to me like IXL is trying to screw with you. But in the real world, you check for extraneous. And that, boys and girls, is the last thing I'm going to do because I am tired. Very tired. By all means, subscribe. Get me up to 1,000 people. And then I can get a little money from YouTube. You know, people get paid for dumb things. Why not smart things, right?